Thank you, Kale. So the next set of slides, we will take you through our journey in implementing IoT and machine learning. So we've been working on this architecture for around 4.5 years, since 2017, where we started off with a GPS-based solution where we were tracking 150 vehicle delivery pipeline. Then we moved on to Google Maps integrated product that was using machine learning and natural language processing for lead generation. And most recently, as Kale explained, we worked with one of the automation companies to ingest data from a pump rig. And then we were using, as you saw, ML models to identify blockages in pipe networks. The architecture itself has been through a number of revisions as well as iterations based on our real-world experience. So every project that we implement, we have a retrospective where we bring in best practices back and implement them. As well as we use the AWS Well-Architected Framework for a continuous review of the services that we use and how we implement them as well. So what you will see is a result of years of reviewing and revising our solution. If we take reference architecture, we have two key features in this. Number one is it's a modular design. What this means is customers doesn't need to implement all the services from day one. We have what's called a co-design workshop, where we identify the customer's needs, a clear understanding of the requirements. We take them through a questionnaire for the architecture, security posture. We do what you call UI designs. And then what the outcome of this workshop is, we have a clear understanding of the requirements, which modules we need to implement, because, as I said, it's modular, so you don't need to implement all the services. The security guidelines and any compliance requirements that the customer has. The second feature is it's well-architected. So as I said, we use the well-architected framework, number one, to review all the service or evaluate all the services that we use in the architecture, as well as how we implement them. And I would say it's highly recommended that everyone use the well-architected framework on a regular basis to improve their products and services. Moving on to the architecture itself, we start off with the ingest module. The purpose of the ingest module is to be able to ingest any kind of data. So it could be data from IoT sensors, corporate systems. It could be from finance or even sales systems. Number two is it should be able to handle thousands or even hundreds of thousands of devices streaming data in near real time, while keeping the cost at a manageable level. If you look at the diagram itself, you will see some of the services that we use, beginning with the IoT core, where which manages all the incoming data itself. So it manages the security, the connectivity, and the streaming of real-time data. We have the IoT core rules, which handles where the data itself lands. So it could be, if it's real-time monitoring, we would send it through, the IoT core rule would send it to Elasticsearch, where we have real-time monitoring, or it would send it to S3 buckets, and so on. S3, we use it at this stage as a raw storage device. So any message that comes through the IoT core or another path, we basically store in a raw format in the S3 buckets. This is so that later on when the customer decides, okay, I want to analyze data which I have been collecting for the past 6 months. It's already there. We don't have to wait for another data set to come through. Lambda is used as an intermediate step for processing and pushing data into other destinations. DynamoDB is used as a temporary storage for ML inference. I will go into a little bit of detail in another slide how we do this and how we have implemented it. The second module, which is actually an optional module at the moment, is the data lake itself. So as you all know, data lake is a scalable solution to process, link, and store huge volumes of data for further analytics. It's not limited by the data source, the type, or the structure. It can be IoT, it could be any other corporate system, or even data from a public API itself. We use lake formation to manage the security, the catalogs, and the labels of the data lake. Kinesis Firehose as an ETL tool for processing data. And S3 is used for multi-stage storage of the data itself. So first one, we would have the landing. Then we would process the data where we add tags into it and security, which is stored. And you will see in one of the other modules where we have another S3 bucket or multiple S3 buckets for published data, where ad hoc analytics can be executed as well. Another module is the analytics data stores. So all the services that you see in this module is purely based on customers' requirement. So when we carry out the co-design workshop, we identify which services they want to implement based on their requirements, based on their budgets, based on the timelines they want to implement the project. So we would, for example, set up an S3 bucket for a very cost-effective way of analyzing ad hoc data. We use Elasticsearch for real-time time series analytics, and if they need some advanced search capabilities, and also API gateway and API endpoints are set up so that internal as well as external applications can access the real-time data as well as the machine learning inference as well. You will see how the machine learning inference comes into the picture later on. But as I mentioned, all of the services here is based on the customer's requirement. The next module is the front end. So as Kale mentioned, when it comes to front-end BI tools, the options are endless. And what we have done in this instance is we have added a subset of services mainly sort of focused on time series use cases. And until recently, we were using Elasticsearch and Kibana as the front end for analytics, visualizations. But we have been getting a lot of customer requests for very customized dashboards. And Kibana can take you to a certain degree, but as far as really customizing the dashboards is concerned, Kibana has its limitations. So what we did was we had an internal assessment of possible solutions or tools, and we selected Plotly Dash. Any of the developers would know what Plotly Dash is, as the default visualization for highly customized front ends. We still use Elasticsearch, Kibana as the real-time monitoring and alert system. So alerts being alerts into SMS, email, Slack channels, or any other solution that supports webhooks. Then Athena will be or might be implemented if the end users want to do some ad hoc analytics or querying. Also, they could use it along with QuickSight for dashboarding as well. And some of our customers have already, what we have seen is some of our customers have already implemented Microsoft licensing. And they really don't want to invest more on another front-end tool. So what we have done is using the API endpoint, we can allow them to access the access data through Power BI as well. So that limitation is taken out, so they can continue to use Power BI, which they are used to. Overall, we are using Cognito as the authentication service, authentication and authorization. And for customers who have Power BI, we integrate their Azure AD with Cognito for seamless authentication and authorization. Any questions so far? Which brings us to the most interesting bit, I would say, the ML Workbench. What we learned over the years is our customers really want to focus on ML itself before looking into other areas. That is simply because implementing machine learning gives them a very fast insight on what are the issues they're having and the ability to justify whatever the budgets they need to allocate. So this modular approach helps them. For example, we could simply implement the ingest and the ML modules itself, and they can identify whatever the issues they're having and then look into allocating budgets and setting up future projects.
If customer does not have any security or compliance requirement, what do you do?
So at minimum, we have a set of guidelines for security saying, okay, at minimum, data needs to be encrypted at transit. Users must be authenticated. Users must have MFA implemented, and so on. So we categorize customers' security postures into light, medium, and heavy. So heavy would be something like a defense-related customer where data needs to be de-identified and then encrypted at transit, encrypted at rest, and so on. So it's, as I said, during the core design workshop, when we go through the questionnaires that we have for architecture and security, these requirements do come up and we can categorize the customer's security needs. In this module, we use SageMaker throughout. And what we do is SageMaker is used for model training and deployment. As you know, SageMaker also provides Jupyter notebooks on the cloud, which integrates with GitHub for version control. Also, it provides the ability to quickly set up developer environments. So our data scientist or whoever the developer doesn't need to keep on installing Python packages on their local machine, setting up Anaconda, and so on. And what we also implement is, if the requirement is there for continuous model training and deployment, we can set that up as well. So the model can be set up to retrain based on certain criteria where is it a scheduled retraining and redeployment, or is it based on a different criteria, and so on.
When you say continuous model training, is it more like one-time training?
Continuous.
What do you exactly mean by continuous model training?
So retraining of the model, basically, yeah.
Okay.
So certain models, for example, we can improve its efficiency or accuracy if we have more data as we go along. New data sets. So if we have more data, we could retrain it with the extended set of data and then redeploy it again. And also, we have the Inference, which is connected to the API gateway. And that allows external applications to use the machine learning inference feature as well. So any application that can connect to an API endpoint can use the inference to get real-time and predictions. At minimum, we use AWS Control Tower and Guard Duty for security, governance, and monitoring. But other services will be implemented depending on the customer security needs. It might be a compliance issue, and so on. So based on the needs, we would implement other services. Good.